Dear students, this is Professor N. Venkatachalapathi, Institute of Aeronautical Engineering. I would like to discuss on some of the problems and solutions in a welding process, which are very useful while preparing or while attempting the GATE and any competitive examinations. Okay, so in the first part, I have discussed some of the basic formulas and some terminology for the welding, and in that some terminology and some formulas which is useful for the open circuit and short circuit current, these type of formulas, and some of the formulas related to duty cycle. With this, we will be able to solve some problems. Let us see the first problem. The problem 1 is arc length voltage characteristics. So this is called arc length. V is equal to 20 plus 4A, 4LA. This is called VI characteristics curve. Okay. And our power source is a straight line. The power source is a straight line with a open circuit voltage of 80 volts and short circuit current is 600 amperes. Determine optimum arc length for maximum power. It is a simple problem, but if you don't know the formulas, it seems to be some tough problem. So this problem has been in GATE 98, I think 2004. In that areas, these questions may ask, and recently also the last couple of years back, these type of questions also they may ask. Not exactly similar. This type of model, they may change a little bit voltage and current dimensions also. Okay, look at arc length voltage characteristics is given by VA is equal to this 20 plus. This is called VA characteristic curve. Okay, and our power source is a straight line. Obviously, when it is a straight line, how do you determine the open circuit? They have given the open circuit voltage is 80 volts and short circuit current is 600 amperes, and we are supposed to determine what is meant by optimum arc length for maximum power. So here the simple mathematical equations only and some derivations, that's all. Okay, with this small mathematical principle you can able to solve this problem. So before going to discuss the solution, let us see the concept of this arc length voltage characteristics and at the same time VA characteristics of the power source. Let us see this is what. So in general there are two type of welding machines. Yes or no? There are two type of welding machines. One is the constant current type and second one is the constant voltage type. So where the first one is, this is called constant current power source. In the x-axis current and y-axis is voltage. The delta V change in voltage, you can see how, and this is called operating point. This is also called the drooping curve. So whenever here, when you touch this thing, this current and delta A is the change in current, and this is the change in voltage. This is the V1 and V2. So delta V is equal to V1 minus V2. This delta A is equal to this A2 minus A1. Okay, like this small. And similarly, when we will discuss about the constant voltage power source, just you can see it is a like a straight line, linear curve, straight line. How the operating point here. So you can see this is the delta V change in voltage here. Obviously, with the first V1 with respect to this A1 and V2 with respect to this A2. Okay, so this is what the changes in current, this is what the changes in voltage, and that is the basic difference between a constant current power source and constant voltage power source. Based on this concept, you can able to apply that problem. Okay, so they have given some constant voltage is given and current is given. How do you determine open circuit and short circuit current, open circuit voltage, short circuit current. How do you determine? So with this, these are the some basic formulas. Okay, in any open circuit voltage, the term open circuit voltage can be defined as it is the maximum rated voltage. Yes or no? It is the maximum rated voltage that can be measured across the two terminal voltage. In general, it is 80 volts maximum. Current is 0. And similarly, short circuit current is, it is the maximum rated current that can be allowed through a welding machine at rated condition. So these are the some VI characteristics curve. X by A plus Y by B is equal to 1. And here IT by IS plus VT by VO is equal to 1. The finally VI characteristics curve V is equal to, or V open circuit voltage is equal to A plus B into LA. With this formula, if you take the any type of welding machine, arc 300 ST, so the specification of this welding machine is, here the input voltage is obviously the 230 or 440. Okay, 230 or 440, and the input power kVA 4.6, and no load voltage is 63, and output current range is 20 to 300 amperes, and the rated duty cycle is a 60%, and efficiency, obviously the 85% efficiency can be performed during this welding machine, and some usable electrode diameter is approximately 3.15 mm. These are the some technical definitions or specifications for an arc welding machine. So whenever, even if you perform some complex materials also, the specifications plays an important role. What is the open circuit voltage, the current, how much, and what percentage of efficiency can be obtained, and what is the electrode dia. All these things should be known, then only can able to easily solve any type of problems. So these are the duty cycle in welding. So this is also one important term in a welding process. The term duty cycle is the ratio of time on load or circuit is on. So this is what T on divided by T on plus T off. Duty cycle can be defined as, it is the ratio of the circuit on divided by circuit on plus circuit off. Okay, so with this, obviously duty cycle, sometimes duty factor. So this percentage on time is 60%, duty cycle is signal, that is on 60%, off is 40%. Okay, so that is what we can able to determine the duty cycle percentage. T on divided by T on plus T off. T on is 60% divided by 60 plus 40%. So like that, you can able to determine the percentage of duty cycle in any type of welding process. Look at in this problem, an arc welding voltage characteristics curve, which is given V is equal to A plus B. So in this given clearly, A means 20 plus 4 into LA. And as you know that VA characteristics, they have given the given data, open circuit voltages. So this is called open circuit voltage, which is given 80 volts. And short circuit current is given, this is called short circuit current, 600 amperes. Okay, we know the power factor is equal to function of LA. So that, as you know, that power is equal to voltage into current. Okay, voltage into current. So before going to discuss about this current, let us see the how the VT. So this VT is equal to V0 minus IT by IS into V. This is the formula can be generated in previous some formulas I have shown. From with this it can obtain. Okay, so with this you can able to formulate the formula VT is equal to V0 minus IT by IS. So where V0 is given, open circuit is 80. You can substitute V0 is 80 minus and IT divided by that short circuit IS, in the sense 600 amperes into V0. V0 again it is 80. So you will get one equation. So this is one equation. And for a stable arc, For a stable arc, what will happen? That Vt is equal to Va. This equation which is related to this, so that this 1 and 2 can be equate V or V, so that is equal to Vt is equal to Va. This Vt means 80 minus It by 600 into 80 minus 20 plus 4 into La. With this you can able to determine It. The current should be determined, that Ic is equal to 450. You can do this equation, simplify. It is equal to 400 minus 30 into La. Okay. So now you can substitute this It in the power equation. This power is equal to voltage into I. So in this equation you can substitute this current, and already V is given some 20 plus 4A. So that power is equal to 20 plus 4A into this 450 minus 30 into La. So that now we can see the dou P by dou Ta is equal to 0. So when the optimum length, arc length is equal to 5 meters. Okay, when you do it, you will get the 5 meters. Okay, and now let us see how you are going to get this thing. You can substitute optimum length is 5, so that this 20 plus 4 into 5 then 450 minus 30 into 5. Okay, so that is equal to 20 plus 20 into 450 minus 3 5s 150. Okay, 20 plus 20 40 into 300. So 4 3s 1 2 0 0 0. So that 12 kilowatt. This is the answer for the power, maximum power. Okay, determine optimum arc length for a maximum power. So while solving this, we'll get the optimum length is 5 mm. So we can substitute the 5 mm in this equation. We'll get the 12,000 watts, and this will convert into kilowatt, 12 kilowatt. So with the simple problem, they are given for 5 marks. Now it is 2 marks for gate examination. So this is about the how we can able to solve the open circuit voltage and short circuit current problems. Okay, I hope the student can clearly understand this simple problem. And another interesting problem. So this also repeatedly they are asking for to calculation of the open circuit voltage and short circuit current. Let us see the problem. Arc length voltage is given by VA is equal to 24 plus 2 LA. So this arc length VA is equal to 24 plus 2 into LA. Yes or no? And during welding, arc length changes from 4 mm to 6 mm. So that means obviously the arc length LA1. So arc length LA1 is equal to 4 mm and LA2 is equal to 6 mm. Similarly, with this, what is the corresponding power source? Current range is 450. So here 450 and 550. Measure here some mistakes they can do. They can put for T1 is 450. It is wrong. Here you can put to 550 amps. T2 is 450 amps. Majority of the students they will do mistakes. So here LA1 is 4 and LA2 is 6. With respect to this, they will add this 550. It is here the 450 they can put, but we should not do it. First, low arc length, high power, high current. Okay, and similarly high arc length, low current. You should take like this 550 and 450, but here they are given for the confusion 450 to 550. Majority of the students they will do for the with this thing. Now let us see, as you know, the equation for VT1 is equal to VO minus 550 by IS into VO, and the second relation is VT2 is equal to V0 minus this 450 by IS into VO. So first we can calculate the voltage with this equation. VA1 is equal to 24 2 into LA 24. So VA1 is equal to 24 plus 2 into 4. Initially 4 mm is given, so that you will get the 32 volts. So similarly VA2 is equal to 24 plus 2 into 6, so that you will get 36 volts. Okay, already have explained in earlier, for a stable arc V T is equal to VA, stable arc both are equal. Okay, so that we will get the two equations. That is, first equation is V0 minus 550 divided by IS into V0 is equal to 32 is the first equation, and similarly V0 minus 450 divided by IS into V0 is equal to 36. This is equation 2. So if you solve these two equations, you can easily determine the open circuit voltage V0 and short circuit current IS. Okay, so if you solve these two equations, in general, how they will do, they can put here instead of 550 450, but that is wrong as per the relation of this graph. You can see whenever low voltage high current, high voltage low current, if you know this principle, then only can able to do that, then only can able for. If we solve this, obviously we will get the V0 is equal to 54 volts, current, short circuit current is equal to 1350 amps. So this is the answer for the simple problem. For gate examinations, they may ask for, it is 5 marks in previously, now it is 2 marks they are asking. Okay, so only thing is the concept of that open circuit voltage in arc length. If you understand that concept, then only can able to get this answer. So suppose if you take first case in 450 means you never get, always time taking. That concept you need to understand. If you have that concept, then only the problem is very simple. So otherwise, whatever you can solve so many times also, it is difficult to get. Okay, so that is why here arc length is given 4 to 6, but the range is given 450 550. But while considering for low arc length, the power will be maximum. Okay, and this also high means power will be less. If you change that thing, obviously this problem is very simple to solve. Okay, so this is about the some of the important welding problems which is most important for the competitive examination, or this may ask IAS examinations and some competitive examinations also. These type of problems they may ask. Okay, so finally what I would like to conclude here is, look at, so whenever the terminology is the one most important in welding. So either it is a butt joint or a lap joint, any type of joint, how we can perform the two pieces can be fabricated effectively. And what about the penetration depth up to which the filler metal can be penetrated with the base material. And what about the reinforcement? The term reinforcement is the amount of material which is projected from the base metal. And apart from that, fillet welding also, how do you perform leg length, throat, and what about the face, what about toe? This and all, if you know clearly about this terminology, then only you can able to solve the different type of problems. And this is the difference between the weld pull and weld bead. The weld pool is in a red color, and how the thickness amount of material which is added to the workpiece is in a single pass. And similarly, the root gap can be explained in a line diagram. The minimum gap at which we can two plates or two workpieces joined together. The depending upon the groove angle only, the metal can be filled with the that filler rod. Okay, and the left side is the deposition rate. How they can perform, you can see while filler rod touch the workpiece, the spark are generated. Due to that only the deposition rate occur. Depending upon DC SP, DC RP or AC, this basic concept you can understand about the what is arc length. So in more heat can be generated in DC only, and DC SP means the only thing is workpiece kept positive, electrode is negative. DC RP means workpiece is negative, electrode is positive. So, but AC is generally cleaning every half cycle, but approximately 50% heat at work, 50% heat at electrode, and the good electrode capacity, current capacity can be obtained in the AC current. But DC, SP, and RP only electrode negative, electrode positive, and the 70%, 30%. 70% heat at the work here, 70 heat at the 30% heat at the work. This is what about the difference between the direct current reverse polarity, at the same time direct polar straight polarity. And coming to this the drooping curve, and how the current is this concept only whenever the voltage less voltage high current, huh? High voltage less current. If this concept if you know, then only you can suppose to solve that type of problems. Okay, these are the some specification of any welding machine. This is called open circuit voltage, short circuit voltage, where the input voltage and rated input power, and some of the output current voltage and rated duty cycle efficiency is almost 85%, and the electrode diameter is 3.15 mm. Okay, and as you know that duty cycle in welding is, it is the ratio of the T on circuit is on divided by circuit on plus circuit off. So obviously 60% duty cycle is a signal, that is on 60% on time, off the time which is 40%. So these are the two problems which I already explained clearly about VI characteristics length curve. So they will give VA equation, A plus VA, and VT is equal to V naught minus IT by IS into V naught. V naught already given 80 volts. 80 minus IT divided by 600 into 80. When it is stable, both equation can be equate. VA and VT is equal to equate. You will get the IC current, and I can substitute in this power equation V into I. We will get the maximum optimum arc length 5 mm. We can substitute this. We will get the power is 12 kilowatt or 12,000 watts. And this is the second problem. Also, the concept of current voltage. Okay, so here the 450, 550 is given. Majority of the student what they will do for first case 4 mm, they will substitute in 450. 6 mm they will do for the 550. If you do that, it is difficult to get the equation, difficult to get the answer. You can change this thing, then only that concept. That is why all the competitive examination they will some twist. That first twist will be you can understand the VA characteristics for how the voltage, less voltage high current, high voltage less current concept will be occur in this problem. And by solving these two, here also for a stable arc VT is equal to VA. So that by solving these two equation, you will get V naught is equal to 54V, and IS, that is short circuit current, is 1350 amperes. Okay, I hope the students can understand clearly how to solve the technical problems in a fabrication process, welding. So majority of the student thinking that manufacturing process is a purely theoretical subject. No, some concepts also which is related to these type of problems are very important. So if you understand this, then only you will do some more research on the advanced welding techniques. Okay, I hope all the students can understand clearly. Next time we will solve some more problems on the different topic. Okay, thank you for information.
Like, share and subscribe. Hit the bell icon for more updates.